Hello learners and welcome to your natural sciences lesson. So today we're going to be dealing with a reaction between an acid and metal carbonates. So now, before we start, did you know that metal carbonates, they actually neutralize acids? So that tells us that they are bases. So in order for us to be able to continue with this lesson, I want us now to start setting out goals and targets that you need to achieve by the end of this lesson. So by the end of this lesson, this is what I want you to know. Number one, by the end of the lesson, you should be able to identify salt, water, and a gas, and that gas is going to be carbon dioxide, as the product of an acid with a metal carbonate. So when an acid reacts with a metal carbonate, I want you to be able to identify the salt, the water, and the gas, which is going to be your carbon dioxide that is going to be formed as a product of this particular reaction. Secondly, you need to be able to state the general equation for the reaction of an acid with a metal carbonate. So basically, how does a metal carbonate form whenever we have this particular reaction? Thirdly, you also need to be able to predict the name of the salt when an acid reacts with a metal carbonate. As we have said, when an acid reacts with a metal carbonate, there's going to be salt, water, and the gas, which is carbon dioxide, that is going to be formed. So I want you to be able to tell me what the name of the salt being formed in that reaction is going to be by looking at the reactants. So in order for us to be able to do all of that, we're going to take the main idea, which is the general reaction of an acid with a metal carbonate, and break it into small pieces so that we can look at those pieces individually before we can look at the holistic picture of the entire lesson. So we're going to start by looking at what metal carbonates are. We're also going to be looking at the application of acid-base reactions. And then lastly, we're going to be looking at the reactions of an acid and a base. So all of these things are interrelated with the today's lesson, which is going to be on the reaction between an acid and a metal carbonate. So now, these are the things that we know now about this lesson, or something related to this lesson. We know that all acids can be identified by the H, which is the hydrogen. So all acids can be identified by the hydrogen atom in front of their molecular formula. Like for instance, an example of H2SO4. H2SO4. This is sulfuric acid and it's an acid, and then it has an H in front of the molecular formula. We can also look at hydrochloric acid, which is HCl. There's an H in front of the molecular formula. So all acids can be identified by that H. Now, the bases, they have a pH that is above 7. Remember, the pH, it is the measure of the basicity or the acidity of a substance. If a substance has a pH value that is greater than 7, it means that substance is basic. Should the substance have a pH value that is less than 7, then that substance is going to be acidic. If the substance has a pH of 7, then that substance is a neutral substance. Now, as we have said, acids have a pH that is below 7, and the further you move away from 7, the stronger the substance becomes, the stronger the strength of the substance becomes. So if you're going to less than 7, then the stronger the acid becomes. If you're going above 7, the stronger the base becomes. And we should also remember that the pH scale, it measures from the range of 0 to 14. Where 14 is a strong base and 0 is going to be a strong acid. Then at 7, as we have said, that is going to be a neutral substance. We also know that the product of the reaction between an acid and a base is salt and water. So whenever we are reacting an acid and a base, the product formed there is going to be salt and water. We're going to have those products being salt and water. And then we also know that that reaction can be regarded as a neutralization reaction depending on the strength of the two substances that are reacting, those being an acid and a base. So should they have the same amount or a complementing pH strength, then they're going to neutralize each other. But should one be stronger than the other in terms of the strength, should an acid be stronger than the base, then the product is going to be more acidic, because the product, the pH of the product depends on the strength of the two reactants, either one of them or both of them. Now, the name of the salt produced depends on the acid and the base that reacted. So we are not just going to name the salt which is being produced by just thinking of a name. We're going to be using the reactants that we had in the beginning, being the acid and the base, and then those are going to be determining the name of the acid. And also those are going to be determining the strength of the pH of that particular of the salt. So the name of the acid and the name of the base will determine the name of the salt. And the strength of the acid together with the strength of the base will determine the strength of the salt that is going to be there. As we have said, if they are of equal strength, strong base and strong acid, then the substance is going to be a neutral substance. Strong acid, weak acid, then the product is going to be acidic. And then strong base, weak acid, product is going to be basic. Now, with what we've just learned now, with what we've just revised now, let's see if whether we can be able to answer the following questions. So the questions are as follows. We need to write down the general acid-base reaction equation. So we know that whenever we have an acid that reacts with a base, they are going to react to form salt and water. And the name of the salt is going to be dependent on the acid and the base and also the strength of the salt. The pH strength of the salt is going to be now determined by the pH strength of either the acid and the base. Now question 2 says, when a metal oxide reacts with an acid, something is going to be formed. So there are two products that are going to be formed when a metal oxide reacts with an acid. So we know that when a metal oxide reacts with an acid, we are going to have salt and water as the product. Why? Because the acid is going to donate the H that was in front of the molecular formula, and the metal oxide is going to donate the O, that is now the oxygen that is going to be that reacted with the metal. So together, those two substances are going to react together and form the water. However, in that particular reaction, we need to make sure that there's going to be a balance of atoms on the left-hand side and together on the right-hand side. They need to be equal before and after the reaction. Then now, question C says, how can metal hydroxides be formed in general? So how can metal hydroxides be formed in general? We know that the hydroxides, they all have the OH. And this metal that you're referring to here could be any metal in the periodic table. But then we're going to commonly use the ones that are either in group 1 or group 2 elements of the periodic table. We know that the elements in group 1, they are called the alkali metals. The elements in group 2 are called the alkali earth metals. So we're just going to be using any of those ones. So how can a metal hydroxides be formed in general? So that is going to be now a reaction between a metal. As we have said, this metal could be anywhere in the periodic table. We know that the periodic table is divided into 3, the metals, the metalloids, which are the semi-metals, and the nonmetals on the right-hand side. Now, the metal, when the metal reacts with H2O or when the metal reacts with water, we are going to be having our metal hydroxide. So when a metal reacts with water, the product formed there is going to be the metal hydroxide. Then now, throughout this lesson, we are going to be making use of words such as acid, base, and pH value to better explain the entire lesson that has to do with the reaction between an acid and the metal carbonates. So we are saying that an acid is a substance that tastes sour and feels rough on one's finger. And we also know that it has a pH that is below 7. Whereas a base is a substance that tastes bitter and feels slippery on one's finger. And also the pH of a base is above 7. Then the pH value that we keep on referring to, that's now the measure of the acidity or the basicity of a substance. Now that pH value, you can find it on the pH scale, which ranges between 0 and 14, 0 being strong acid, and then 14 being strong base, 7 being a neutral substance. So before we dive into our first concept of the lesson, we're just going to go over a quick ad break, and I'll see you just after this.